Good morning, everyone. My name is Pierre. I'm delighted to be here today to introduce Data Lab. So, as an engineer, as a scientist and a software developer, I've dedicated much of my career to developing tools that merge scientific applications and industrial applications. And I think that Data Lab is a good example of such a tool. So let's begin by briefly introducing myself. So I'm an engineer with a background in optics and photonics. And along my career, I have the opportunity to work on at the intersection of scientific and industrial worlds. For example, at the CEA, the French Atomic Energy Commission, I was involved in scientific experiments, and I was working with industrial partners on various projects. In 2018, I made a shift and I joined one of those partners, Codra, a French software company. So now CA is one of my clients, and I'm helping them to developing scientific data visualization software or device control software or any other specific software. My passion for software development has always driven me to contribute to the open source community. So back in 2008, I created the first all-in-one scientific Python distribution for Windows, Python XY. Even if the project has now been discontinued, it laid out the foundation of scientific computing on Windows at that time. In 2009, I developed Spider, the first ready-to-use scientific Python IDE for all platforms, and it's now one of the most widely used IDE for scientific purpose. Let's run Spider 6, for example. This is the last version of Spider, which was released a week ago or so, and we will get back to it during the demo. So here it is. A few years later, in 2012, I've introduced WinPython, the first portable scientific Python distribution for Windows. So WinPython essentially took over Python XY, and it's still active today. In fact, at Codra, we distribute most of our Python project on Windows using WinPython. It's completely free. And last year, I've launched Data Lab, the first the scientific data processing platform, which we will be talking about today. So let's launch Data Lab briefly. So here it is, and I will hide it because you're not ready to see it yet. Okay, so the focus of my talk today is to answer, hopefully, three questions. The first is the what. So what is Data Lab? How to begin with Data Lab, so that will be easy. And why use Data Lab? So let's start with the what. So Data Lab is an open source platform for processing and visualizing 1D signals or 2D images. So it's a desktop application. We'll see why. And it's made to process data locally. So it's built on top of Python and scientific libraries such as NumPy, SciPy, scikit-image, OpenCV, or the PyData stack. PyData stack is a stack of libraries for visualization in Python and Qt, which is quite efficient for image visualization in particular. So initially, Data Lab was developed for pre-processing experimental results on the Laser Medical LMJ facility. LMJ is one of the largest ICF experiments in the world. ICF stands for Inertial Confinement Fusion. That is actually heating some fuel to reach nuclear fusion here in the context of weapons simulation, atomic weapons simulation. And so LMG involves a lot of devices, among them plasma diagnostics, which are a set of equipments to measure different physical things like optical images, X-ray images, or X-ray spectrometry, and so on. And so those diagnostics have a lot of devices, scientific devices, such as digitizers, ultra-fast cameras, spectrometers, and so on. During an experiment, there are a vast amount of data that is generated by those equipments that need processing. So that's where Data Lab comes in to process 1D signals or 2D images for this purpose. So as a side note, note that Codra develops and maintains LMJ, most of the control system on LMJ diagnostics. And it is really a massive facility with thousands of equipments. So why did we create a Data Lab? So the first goal was to provide a generic solution to our clients' data processing needs. So that's quite a classic. We did it generic from the start because we wanted to release that open source as an open source software. In that way, it would be reusable for other projects, and in the context of LMJ, it makes Data Lab reusable from other plasma diagnostics. We also needed to provide an industrial-grade solution, so that one is original for a scientific software, because often scientific software and reliable and robust do not play well. So here we needed to be as reliable as the control system itself, which is industrial grade software. Finally, we needed to provide validated algorithms, so we will get back to it, but the main goal was for the LMJ to have accurate and reproducible results. So the 4 key strengths of Data Lab are, first, the extensibility. You may, if the integrated features do not fit your needs, you may extend them using plugins, macro commands, or by remote control Data Lab from your IDE or notebook. It is interoperable, so you may embed Data Lab in your Python application. You may also remote control it from any application, Python or C++ or anything else, because it uses a standard protocol to communicate with Data Lab. It is fully automated. There is a high-level public API which was initially made for testing purpose, but which is also used for communication, for controlling Data Lab remotely. And finally, it's maintained and it's really testable. We have an automated test coverage of 90%, which is quite a high figure for a GUI-based software. We test everything, almost everything. Sometimes my clients mock me when we find a bug, and they say that it's in the 10%, but we can't test everything. So just to illustrate how much we test Data Lab, here is the demo effect. Password. Pierre. Yes. No, it was at least a bit stronger. So here is a test suite using PyTest on Python, on different version of Python. Here it is on CentOS because it was one of the platform aimed by our client, and we test Data Lab for multiple Python version and multiple architectures as well. And we also test intensively the PlotPy stack, which are the libraries, the different layers of libraries on top of which Data Lab is built. And here you can see all the unit test runs on different layers, starting from QWT, which is the lowest layer, to PlotPy, which is the highest layer. And it is tested on 3 versions of Python with different PyQt bindings, PyQt 6, PySide 6, or PyQt 5, and different version of NumPy also. So it's quite tested. So let's do a quick demo. So I'm sure that there are some Windows skeptics in the room, so it is cross-platform, and I'm not sure I mentioned it earlier, but let's show you. Let's prove it to you. Let's run it from Ubuntu, for example. It should work. Okay. So here it is on Linux. There is an integrated demo, so let's start it to convince you that it works on Linux as well. So here it shows the signal processing part, just doing basic computation, basic filtering, curve fitting, peak detection, and some properties calculations like full width at half maximum, things like that. Then we switch to the image panel, and again some basic computations, some filtering coming next, rotation and so on, and region of interest management, and some contour detection, and so on. So let's interrupt this here. Okay, and let's switch to the Windows version. So here it is. So also, Data Lab has a lot of I/O features. It supports a lot of image types, for example, and you can add more through plugins, of course. It also has an HDA5 browser to open data from HDA5 files, for example, this one. You can preview the images or signals that are stored in HDA5 files, and you can import them all at once, for example, here. And here you can see the workspace where we put the signals and images, and that can be saved and reloaded afterwards from an HDA5 file. And regarding images, you have a ton of features. For example, intensity profiles here, processing features. Here you may recognize some filters categories that are directly coming from scikit-image, like noise reduction, thresholding, exposure, morphological filters, and so on. So we can do some edge detection, for example. We can test all the filters at once, just for the demo. Makes no sense in that case, but just to show you something. And once it's done, we can distribute the images over a grid. No, that's not what I wanted to do. Sorry. And once it's done, we can add the titles of the images to see which one. Yes, okay. So we can compare the different filters quite easily, and change parameters if you want for the different filters, and see what it is doing. So we have also more features in the analysis menu, like 2D peak detection, contour detection, or blot detection. And we also have plugins. So there is a default plugin integrated in Data Lab that shows how it works, but you can write your own, of course. And we also have a macro editor which uses exactly the same API as the plugin. Here is a very simple example that we can run to see what it does. So it adds an image here, a random image, and it computes the FFT. So this code, we can take it and run it from Spider, for example. So this is a completely different environment, actually. Here, Spider is running on Python 3.12, and here, Data Lab is running, as So you can see in Python 3.11, if I remember correctly. Yes, you see it here. So it's not the same environment. So let's run it. So it won't work like this because I don't have installed the whole data lab package, but you can install only the simple client, which is a lightweight client and does not require all the GUI dependencies, for example. Okay. And this is the demo effect. Okay. So it connected to DataLab, and it did exactly the same as I did before from DataLab, but from Spider, and the connection was automatic. So this way you can mix your own algorithms with DataLab integrated algorithms and send data to DataLab and retrieve the results, the processed images or signals, or the computed parameters, and so on. And of course, it works exactly the same in a Jupyter notebook. So how to begin with DataLab? That's quite simple. So there is a very comprehensive documentation with all the features, tutorials, public API, and so on. And to install it, you have plenty of choices on different platforms. For example, on Windows, you have an all-in-one Windows installer, but you can install it by using Conda, for example. So that is quickly said, but prepare such a comprehensive documentation and to have all these channels of distribution required quite a lot of work. So why use DataLab? So imagine you have a dataset to analyze with Python, so you will need libraries. And before that, you will need to be able to read and edit your data, to visualize your data, and to fine-tune your algorithms. So you may do this with your usual general-purpose environment, like an IDE, preferably Spider, or a notebook, a Jupyter. But what I'm going to show you is that DataLab could be used as a complementary tool. So why use it as a complementary tool? Because prototyping a processing pipeline using only scripts is powerful, of course, because all the features are there. The features, after all, are in the scientific libraries themselves, but fine-tuning their algorithms required to be able to manipulate the data and to change the parameters very quickly to test different combinations. And this is done far more quickly in an environment like DataLab. So DataLab provides hundreds of signal and image processing features, a workspace, as we saw, straightforward interface for rapid testing and to test all those parameter combinations, a communication system with your IDE or notebook, so you can combine your own libraries with DataLab features, an external infrastructure using Python script, as we saw. So the little code that we saw as a macro command can be used as a plugin using the same API and use as we saw from your IDE or notebook to control Spider using exactly the same API. DataLab has 3 operating modes: standalone application, so that is the basic operating mode, a library, so you may use all the features of DataLab from your Python scripts as a library, or a remote control application, so you may control DataLab from any application, Python or not. So let me show you those 3 operating modes through the following use cases. So the first use case is the most simple. Actually, it's the standalone mode. So it's just easier to prototype your processing pipelines with DataLab because it's like a Swiss Army knife. You have everything you need in the same application. The second use case is the fact that you may prototype your processing pipeline using your own IDE, for your usual IDE or notebook. So you write your scripts in your IDE or notebook, you send data to DataLab, you process them in DataLab, then you send them back to your IDE. And when you are when you have an algorithms ready to use, you may also write a plugin in the lab to integrate it for your future analysis. The third use case is to debug your processing application. So you may establish a direct communication with data lab from your application and add breakpoints in your IDE. So you will be able at each breakpoint not only to visualize the state of your variables classically, but you also be able to visualize your data, to manipulate your data at each step of your algorithm, which may be quite useful to understand what's going on in your algorithm and to be able to debug it. So that's exactly what we did with an application developed for the CA. Unfortunately, I can't show you the demo today because there is a patent pending, maybe next time. And that's a pity because it's a very impressive demo because we see exactly how the algorithm works step by step by showing the intermediate results, intermediate processed images, and the computed parameters shown on the images. So maybe next time. So the application is an image stitching application based on automatic pattern recognition on X-ray images. So the fourth use case is to enhance your application with advanced processing features. So as I said, you may use DataLab as a Python libraries to leverage more than 100 processing features, or you may use DataLab as a companion to your application. To let DataLab process your data and use the process data from DataLab in your application. So that's what we've done with on another context at the CEA on the LMJ. So this is an application which is used to control plasma diagnostics. Each plasma diagnostic consists of a dozen or more scientific equipments like cameras, scientific cameras, digitizers, spectrometers, and so on. And here we are sending the alignment images taken from a scientific camera to DataLab for processing, and we are computing some alignment parameters, and we are sending back those parameters and the processed images to the main application. So actually, we have developed a dozen of applications like this for the CEA, and it's used in production on the LMJ facility to pre-process the results. So this is a standalone version of DataLab that is deployed on the LMJ, and we have developed specific plugins for processing each feature that was needed for each plasma diagnostic. So here is a closer look to the application where you can see the alignment images and the icons of DataLab that shows the link with the application. So another reason to use DataLab is that because you can extend it with its features with plugins. So the DataLab plugin system allow you to add features like processing features, also I/O features, providing new file formats, and also features regarding AGF5 support. You may add new AGF5 layouts and metadata. For example, for the LMJ, we have developed plugins, processing plugins, I/O plugins, and AGF5 plugins to support, for example, the experiment AGF5 files which are quite specific, and to detect in each file what is an image, what is a signal, and extract metadata, and so on. So plugins are easy to develop. You only have to write a simple script and you may prototype it from your IDE. As we saw earlier, it was the beginning of the writing process of a plugin in some sort. They are easy to deploy because you simply have to copy the plugin file to a folder. They are easy to reuse because the plugins are using the same API as microcommands or remote control features. Another reason to use DataLab is that it's validated. So we have two types of validation. Functional validation, which is quite classic. We have a fully automated unit test suite, as we saw earlier. So so we follow the TDD principle, and we covered so 90% of the code. And we also have a technical validation, which ensures that the results are accurate and reliable. That's quite important for applications such as the LMJ, for example. And for this type of validation, we have a coverage of 84%, but it's a work in progress. So here you see the online documentation, and if we open it, we will see that what is the status of the validation of Data Lab. So the functional validation is another topic. It's the classic automated test suite. And for the technical validation, you see here a summary of the results, all the computing function for signal processing, image processing, and the coverage of those functions. And for each one of them, you may see exactly how it's validated. For example, if we take the FFT computation, you may directly open the test script where you see here it's for signal FFT. You see how we check that signal FFT is performed correctly and the results are accurate. So today we saw that what is Data Lab? So an open source platform for signal and image processing. We saw how to begin with Data Lab. We saw why use it. And I would like to take the time to for the acknowledgements. First, a big thank you to the CEA and Codra for the project funding. A big thank you also to the contributors, because all the for contributing on the documentation or reporting bugs and so on. And finally, the package management, because as we saw, Data Lab is distributed on various package managers, and I've done Debian, Ubuntu teams, Conda Forge teams, and XOS teams. I've done a wonderful work and far beyond only package management, and it was a really good way to ensure that the lab was robust and reliable. Thank you.
Thank you. Do we have any questions?
Thank you for the interesting talk. My question is about 3D image processing. Do you have any plans on integrating 3D image pre-processing in Data Lab?
I'm sorry, I didn't get the last part of the questions. Sorry.
Do you have any plans on integrating 3D image processing into Data Lab?
Not right now. Actually, we have plans for integrated another panel, which is a time series panel, because for now there is only signal panel and image panel. But 3D images it's not we do not have use cases for the moment, but maybe in the near future.
Thank you. I had another question, if you have time. Do you plan on adding more libraries from Python, like TensorFlow or any other libraries that can do image processing?
Yes, of course. Actually, we are adding new features every month, also, and the new features that we add are fully related to the use case that we have to work on with our clients. So we develop specific plugins that can be proprietary, so not open source, but most of the time we have the opportunity to enhance the open source version of Data Lab. So yes.
Okay, thank you.
Hello, thanks for the presentation. Have you talked about HDA5 file format? Are there any possibilities to deal with CSV files?
Yes, of course.
Yes.
You may import CSV files from Data Lab as signals, and it also supports. It also has an import assistant. So here you can import CSV file. We even had a use case for very huge CSV files like something like 3 or 4 gigabytes CSV files, and it works quite well. So CSV files that you can't open with Excel, you can open them in Data Lab.
Thank you. So I think there were more questions, but since we are out of time, so if you want to ask more questions to our speaker later during lunch or the break, so thank you.
Thank you.